Hi everyone. We're going to find the value of our angle theta in degrees, round it to the nearest tenth of this figure here. So we want to know what theta is. So basically what we're going to do is draw a line segment from the vertex of the angles through the centers of the circles, which bisects this angle into two. I'll put it in red. So we're going to bisect this angle here, go through here, and then this is going to be we're going to have two triangles. So we have a right triangle here and one here. Instead of me copying this over, so basically really quick, we have this little triangle here. Then we have this larger one that goes from here to here, if you're not very visual. So we have a little one inside the big one, basically. All right. So basically, what we're going to do is try to find theta. Right now, since we have this one right here is theta over 2, and this is theta over 2, because we took half of theta and divided it by 2. And what we want to find here is theta. So we're going to let this portion right here be x. Alright? And we got to solve for this. So we know that the radius is 2, so this is 2. This length here is also 2. The length of this bigger circle here, since the radius is 4, is 4. Okay, so what I've got to do is find x, and so we can find the hypotenuse. So our hypotenuse is right here. We want this hypotenuse and the one for the larger one. Okay, so the first thing I'm going to do is find the hypotenuse. So we know that the hypotenuse of the smaller triangle is going to be x plus 2. So it's this length, this hypotenuse, plus 2. So the smaller triangle, I'm going to put small triangle hypotenuse equals x plus 2. Alright? And the hypotenuse of the larger one, so the larger hypotenuse is this whole length here. It's this whole, the big one. So I'm just going to add everything up. So the large triangle hypotenuse equals this x here, plus the 2, plus, let me do this in blue, plus another 2, plus the 4. So this is going to be x plus 8. Now, since these are similar triangles, we're going to solve for x, so we can find this x right here. That way we can solve for theta. Alright, so I'm going to do x plus 2, this hypotenuse, over my radius equals x plus 8, my hypotenuse, over my radius. And then cross multiply. So we get 4x plus 8 equals 2x plus 16. And we're going to subtract. So we get 2x equals 8. So x equals 4. Now what I want to do is I just now want to deal with the smaller triangle. If x is 4, then the length of this is your length, of the smaller hypotenuse is going to be 4 plus 2, which equals 6. So this length here, I'll try to get a different color. This length here, the hypotenuse is 6. Now I can solve for theta. So what I'm going to do is solve for theta, and I'm just going to use this triangle right here and set it up. Alright, so sine of theta over 2 equals 2. So this is, for my angle, it's opposite over hypotenuse. So that's going to be 2 over 6. So I'm going to inverse both sides. I get theta over 2 equals inverse sine. I'm just going to reduce that as 1/3. Now that gives me, if I multiply both sides by 2 here, I get 2 sine inverse, or inverse sine of 1/3, and that yields 38.9. Whoops. 38 point, I'm too far at the bottom here. 38.9 degrees. I'm not going to be able to get it. So right here, this theta equals 38.9 degrees. And that's your theta. And that's all. Thank you and have a nice day. Bye-bye.